So, hello everyone. I'm Simon Lallemand, and I work as an architect in infrastructure at BlaBlaCar. And today I wanted to share the way that we switched all our production to containers, and especially the way that we build all our containers in a way that scales. So, first of all, just a few words on BlaBlaCar for those who don't know what we do. We're actually a city-to-city ride-sharing service. So what we do is basically to connect people that seek to travel with drivers going the same way. Then they split the cost of the trip. And over the last few years, we've got an exponential growth. So we had to deal with that on an infrastructure level. And we've also reach a lot of new countries. So right now we're present in 22 countries. So on the infrastructure part, we run all our infrastructure on bare metal servers. And well, one of the reasons of that is that we've always done that. And when you've learned to do it, it's cheaper than cloud. And that's what we have right now, or last Friday when I checked, we had almost 200 services and more than 2,500 containers running in production. So to run all that, we're using CoreOS. So that was mainly because it was made to run containers, and it's really easy to install on cloud. We started installing CoreOS with Chef, and we recently switched to use Ignition, which is really great. You should try it. And when we had to choose which runtime to use, it was early last year, and Rocket just came out. So we had to choose whether going to Rocket, which was more architectured for what we thought, and or using Docker, and we did give a try to Rocket, and well, it works pretty well. So, but there's one problem, because when you're using Docker, you have everything that you need with Docker files, with all the tools that the community made to build your containers. And when you're using Rocket and you want to build your Ekis, well, at that time, there was not much to do. You just had to make a file system, you start, and move it to a repository manually. Yeah, that was a pretty pain in the ass. So we asked that question, how we build an Eki, and we came up with one tool, not at once, actually. We tried before using Chef, because we knew Chef and everything to build all those Ekis. We tried to use Packer, and we tried lots of things, but none of them was either efficient enough or offered us enough flexibility to customize the containers at runtime. So we built that tool that's open source, that's on GitHub. And what actually it provides is a standard way of describing the way we'll build the containers. So we'll have such a tree infrastructure. We'll have an Eki manifest, which is basically the same manifest that we will find in any Eki. And then the attributes for this Eki, a bunch of run levels. I will detail later what they do. And the templates for all the config files that we will find in the container that we want to run. So basically what's in the manifest is just this. We use the YAML format because, well, it's easier to write than JSON. But the format structure is basically the same that what you find in JSON. One particularity that we use from the AppC spec are the dependencies, because we don't have the layers that exist in Docker with Rocket, but we have the dependency mechanism, which is much more powerful, because you're not doing only one-way dependencies, so you don't have a tree on one way, but you can have one Eki that depends on several Ekis. That is especially useful, for instance, if you want to make I don't know, a container running a web server, and you have the content of the web server in another AKI, and you just make a combination of those two AKIs, and you can make either the web server part or the code source of the website you're running evolved separately without rebuilding the AKIs that uses the both AKIs. So that's what we do here. When we're building the AKI Redis, we don't have the Debian base included in this AKI. So as I told earlier, there is a run level, different run levels. The first one that we made available was the run level build that actually made all the build steps that we want, basically what you would find in a Docker file. And it's executed on the file system of the container. So here you can see that we have an install.sh which will have basically all the steps that you need to install what you need. It's very simple. It's just a apt-get install Redis server. So here, as I said, you're running build run level in the container. But sometimes you want to run things outside of the container and just put what you need in the container and not everything. So for that, we have the run level builder. And the run level builder will allow you, for instance, to make the ACI Debian, because otherwise you can't build the ACI Debian from the ACI Debian. That wouldn't make sense. So what it actually does, you will have a script like this, which will be executed also in a container by Digger, and it will download the debootstrap and just put the resulting debootstrap in the rootfs. So you will have only what you need in that rootfs. But it also works for if you have a packet manager that can use a different target than the slash to install the binaries and everything. For instance, Gentoo, you can have here we have a special builder that has for dependency Gentoo stage 4, so in which we have emerge, and we'll be able to just do emerge of LightGTPD, for instance. And it will put all the LightGTPD binaries in the rootfs, and we will have only that and nothing else in the container. So that's very useful to make containers without all the overheads that you would have when using a whole distro as a base. Another run level very essential in Digger is the prestart. Because we didn't want to build a container per usage that we have, a container per service that we have in the infrastructure. So what we do is that we render the configuration file and we initialize everything during a prestart phase. So that, again, we didn't invent anything because it's a hook in the AppC spec that you can use. In that hook, we use a special Digger binary to render all the templates and to execute some scripts that we want at the beginning of the launch of the container, just before that we launch the actual binary that we want. So, for instance, you will have for Redis, we'll have the configuration which is templatized, and the template is in the AKI, and it's not resolved. And we'll have also the attributes will be in the AKI, and we'll create the configuration from those two parts only during the prestart. So here you have an example. It's Go templating. So here we just have an attribute for the Redis port, and this will allow us to change that. I will talk about it later, either when building a pod or during or by passing arguments when you run the container. And then, as I said, you can also have some scripts to init the data or anything during the prestart. So the prestart early basically will execute before the templates, and the prestart late will execute after the resolution of the templates. One other feature that we have in Digger is testing, because once you build your keys, you want to test, see if you have not broken anything. And for that, we have a special directory still in the same tree, so that's called test. And we'll have there two scripts. So the first one, wait.sh, is just, you put in there just what you need to wait until your service has started so the test can execute. And in the bats files, you put bats test. So for instance, for an Nginx image, you would test if the Nginx is actually running and if it's listening on the right port. So yeah, basic example. So just to give you an overview of all the commands that we put into Digger, we have Digger init. So basically that will just produce a standard tree for building an AKI, and I'll show you later, with all the directories that you can use. There's also Digger try. Digger try will allow you to test your templates with the attributes that you have without building the container. So that because when using Digger, we found that it was a bit too difficult. It took too much time just to build the container, run it, and just I forgot some attributes and it doesn't work. So we did that Digger try. There's also Digger build, so that one is to actually build the container and produce the AKI. Digger test will execute the test for the containers. Digger install will take the build container and put it in the local store of Rocket. And the Digger push will push it on an external repository. For now, it only supports Nexus from the Java world repository, but we plan to do more. So once you have an AKI, you might want to build some pods. So actually, you want several AKIs in sharing the same context. So for instance, you will have something like this, because you can. We have the same way we have AKI manifest in Digger. We have also pretty much the same directory structure to build the pods with all the apps that you want to run at the same time. So here we want to run Nginx and the PHP app, for instance, in the same pod. After that, you can build this pod, and it will produce two AKIs. So one will be called pod myapp AKI Nginx, the other one called pod myapp AKI PHP, and you can run them with Rocket like this. But now, maybe you want to contextualize some things there. So how we do that? We can actually override the attributes that we had in the previous AKIs without rebuilding the initial AKIs. So we can put extra attributes either in the pod. So for each AKI of the pod, we can say, I want to override this attribute or this one. But we can also override the attributes at runtime using the environment variable templater override. And we put all the context in a single variable. So that's better than what we see very often, having an environment variable for each parameter that you can have in your container. Because here you can put a full context in a JSON array in a single variable. So what we have after that is something like this. You just Rocket run your AKIs with the context that you pass. And as you can see, I put that in a template way, because what we've done is another tool to simplify the way that we push the containers. and the way we produce these JSON attributes here, because yeah, it's a bit difficult to write just JSON with all the variables. That's what we did at the beginning, but it was really complicated. So we made a tool called GGN that will take a bunch of attributes file and just create the units from the template that you just seen before. And GGN is actually a wrapper over Fleet. So yeah, we're not using a very, how would we say that, evolved orchestrator. We're just using Fleet for now because, well, it's still better than what we had before. We can just deploy new services with just a command, modifying some attributes in a file and just running Redis update, and I will have changed things. We can, like this, we can update a whole cluster. For instance, I could write GGN prod Cassandra update, and it will update, roll update all the Cassandra cluster with the new attributes I made with the new containers. So that's something that we use to have a better life as operators of the platform, but it's definitely not where we want to stay. We want to go further with the real orchestrators. Yeah, and the link here is not good. It's broadcast, so GGN. So yeah, what's next? So as I say, we want to make several improvements on that. Particularly, we want to sign the SCIs because it's not something that Digger does at that time. And we want also to push the keys to other repositories like Quay.io or other things, because at the beginning we needed something to do things fast, and so we picked a repository that we already had. But yeah, we see that there are some limitations. If you want that you guys can do something with the tool, we need to support other kind of repositories. And the last thing that we want to do also is, of course, to orchestrate the things a little bit better, and for instance, to produce from the attributes what we would need to use Rocket Natives, for instance, or such things. So that we're just on the exploratory phase right now, but we should move this year on that. So now maybe I can do a little demo, if it works. Yeah. So here I will just log in a CoreOS box on my machine. And yeah. So you have some examples in the Digger repository if you want to try it. That would be here in Digger examples. So for various distributions and everything, you can try all that. So right now we just build a Redis container. So here I will have, as I said, the several directories. So I have an Neki manifest, attributes, runlevel, and templates. So in the manifest here, I'll have the name of the name and the version of the container, what I want to execute, and the dependency here is Debian. And how do I build it? Very simple. Just have a build runlevel with this command here. After that, I have also some templates. That's here. So just to customize, for instance, the ports, the max key, and max memory. And the default attributes are located here. Yep. Like that. So here, the only thing that I have to do is a digger build on that. And it will fetch the dependency that it needs. Here I have everything in my local store, so it will be faster. Then execute the apt-get. And at the end, it will produce an image.aki in the target directory, so that would be here. Yeah, I have the image.aki here. What you could see here is the inherit build date. It's actually another run level I haven't talked about. It's a special run level that you can put in any aki that will be inherited, and that will be executed by when you build other AKIs that depend on the first one. So here I depend on Debian, and in Debian I have something that says at the end clean up all the apt stuff, so I won't have it in the aki. Once I've done that, I can digger install this aki. And now, if I have a look here, I will see the Redis, just here, the Redis image that has been added to the local store. So after that, what I can do is just to run that. So as I said, there's no signing yet of the AKIs. So I have to put this. And now I can see that the Redis server is running on the port 6379. Now let's say that I want to build a new service that needs Redis, but not on that port. So without rebuilding this, I could just add the variable that I told you earlier that would have been built by GGN, but in that case, I can't do a demo about GGN because it uses too much BlaBlaCar stuff for now. So you can have a look at it, but it won't work as is. Here, so can use this line. So here, as you can see, I'm just changing the port to 6666 and running the same thing. And there's something wrong here. Insecure Europe. Can everyone see it? Maybe if I put some quotes here. Yeah. So now it's running on the port 6666. And maybe one last thing that I can show you will be if you want to build another aki, but you don't know exactly where to start or anything, you have the command digger init. So you just create a directory for your app. You go in that directory and do a digger init there. And there you will have all the directory structure created for you with some dummy files and dummy attributes, so that you can easily start from there. So that's it. Do you have any questions?
Hello, I'd like to ask you, where do you deploy the Redis? Because I saw you deploy the PHP and a web service. Did you deploy the Redis in the same port, or where did you deploy?
Actually, we don't use that that example at BlaBlaCar as is, because we always deploy pods for each service. And for the Redis example, for instance, we'll deploy a Redis pod that would include an ACI Redis like this one, but also an ACI with everything to monitor the service Redis. And we also have, because we are using Redis in a kind of cluster way, so we made a tool called Redis Dictator that sets up the Redis replication automatically and elects a leader using the keeper. So that's 3 or 4 keys just for the Redis pod where we use it. And we are using 1 IP address per pod. So here it wouldn't make sense to have Redis key in the pod of the Nginx PHP. So we have separate pods for all the services, and we run each time directly the binary that we want on each key. We don't have things that, such as entry points or everything, because we are doing that in the prestart phase. So yeah, I don't know if that's answered your question.
All right, well, thanks for the talk. The next talk will be at 2:20, so go grab coffee and see you all back here then.